So yeah. Oh, okay. Hello everyone. Thanks for coming to this talk. It's the last session before the closing keynote, and we are going to tell you about our migration to Jenkins pipelines, and along the way how we developed a framework to let you test these pipeline scripts. So first, introduce ourselves. Oh, the mic is not working. Okay. Mine is working.
Yeah, yours is working.
Okay.
So let's present ourselves.
So yeah, Emmanuel is developer at Slefray, and I'm also. I guess it works. No. Okay, yeah. So we are basically Java developers, and we sometimes use front end also. Is it okay?
Yep.
Yeah. Let's go. So you can find our Twitter handles there.
So lesfurets.com, it's a first insurance comparison website in France. Les Furets in English, it's a ferret, the small animal. So we are operating since 2012, and we compare about 5 projects like vehicle, home, health, and so on. And we work with 50 insurers.
Yeah.
And we are doing about 3 million quotes a year. And if you do a quote, if you buy with Les Furets, you will get a small toy, as you can see.
So at the delivery team, we have 20 plus developers. In parallel, we have 30 developments each day. And daily, we deploy to production since 2014. That makes more or less 220 releases per year. I guess that year we had 260 or something.
So how we doing all that much releases a year? For sure, we do continuous delivery. And this continuous delivery is done with feature branching and continuous integration. So when we do feature branching, of course, we do one branch per development. And we have an internal tool, which name is Octopus, which merges all the branches into a new branch, which will be deployed on a staging environment. And every day, we take all the branches which have been validated, and we merge them together, and we deploy them into production. So thanks to that, we have isolated developments, because we have this feature branching and this isolated validation, and we have early feedback when something goes wrong.
So yeah, we have the advantages of feature branching and continuous integration together. Yeah. So before migrating to Jenkins pipelines, we had that continuous delivery pipeline. So we had 2 source code management systems, one for application code, the other one for build scripts and deployment scripts. We used TeamCity and Jenkins together, and we configured all our jobs on the UI, and we said about feature branching, and all the CI jobs, the build and tests, were using a shared development database, which caused lots of problems, of course. And as far as feedback, we had only the Slack notifications hard-coded on the script, on the deployment script, and that's all we had. Yeah.
And the configuration of our jobs were done in the UI, in the old-fashioned way.
Yeah. So when you want to change something there, we usually broke it. And yeah, we had multiple repositories. We didn't have any artifact repository.
And after the migration, we had this new pipeline, or this new process. We gathered pipelines code and application code into the same HCM so that they can evolve together. We automated the database migration with Flyway. We added some Slack notification. Our tests were using an isolated database thanks to Docker and MariaDB. And we added an artifact repository to make some lazy packaging and to store our artifacts. And all of that are now using Jenkins pipelines.
Did you talk about the mono repository? Yeah, we have just one repository with all the pipeline scripts and application code.
Yeah, at the beginning.
Yeah, so that way, every evolution that we did into that pipeline were tested and released with the same process. So by migrating to pipeline as code, we gained the ability to coordinate tasks. We were able to handle the errors and do some retries, parallelize stuff that was important. And most importantly, we separated the configuration of our jobs and the deployment scripts from the shell scripts, and we migrated them to Groovy scripts. We, I guess, simplified our shell scripts. So there was no configuration yet, just what should be done in the shell script. And all done.
Yeah, everything is perfect.
Yeah,
thanks
for coming. So yeah, we could go to vacation, but it wasn't that easy, of course.
Yeah, we have still time.
Yeah, so I guess when we are migrating, we pay the price of early adoption, right? Yeah. The documentation was not there, and it was a rough road.
So one first problem we had was the workspaces and the multi-branches pipelines. I don't know if someone in this room has already used it, multi-branch pipelines, but I hope so. But when you do that, if you have like 100 branches in a month with 1 gigabyte code in your repository, each agent will probably create one workspace per branch just because you have multi-branch pipeline. So with 100 branches, 1 gigabyte, it's easy to compute, 100 gigabytes, and you have no automatic cleanup. So when your branches dies, then you still have the workspace. So really quickly, we had no more space on disk. So with like 10 agents, it's a big issue. So we tried to find a solution to this issue.
Yeah, the first try was to clean the workspace, just in case before and after the job. Well, the disk usage problem is solved, but we had to clone the branch all from scratch. So this stressed our Git repository, of course, pretty much, and it was slow.
Yeah, the clone lasted like 1 minute at every validation. It was too much. So our second try was to share the workspace among all the branches. So for the same multi-branch pipeline, we forced, as you can see here with the WS validation, we forced the workspace to be validation, and then all the branches were using this workspace, and in the same agent, you will have if you have only one executor, it will use this workspace. And at the beginning of the job, we do a checkout, as usually, and then we clean everything, just in case the checkout has already done before, and we have some old files of the previous execution. So everything works fine now.
Yeah.
The checkout is quick, and the workspace is reused, so problem solved.
Yeah. So that was just one of the examples that we had with workspaces and all the Python scripts. But from the beginning, we tried to simplify things and like apply the good practices of software engineering. And one thing that we do is to split the jobs, the scripts from the jobs, into little pieces that does only one thing. So as you see, for the deployment job, we split it into 5 little pieces: check packaging, flyway, post-deploy, Seleniums, and Tomcat. So yeah, each of the little script pieces were as like that. Like for example, for the flyway, which downloads the artifact from a repository or from our artifact repository, unzips it, and applies the migration. Yeah, we have always this return this for that this script can be called from another script. To do that, we wrote a little script loader that loads all the scripts and injects to variables so that we can, like, the commons can be called from other scripts, which is a shared library for our case, but in a monorepo version. We had several of those, like Jira API and script loader. So using the internal feature of Jenkins to load scripts, we had this structure of our pipeline scripts.
So all these changes we did to our pipelines were done by trial and error. Some talks I have spoken about this problem. Sometimes you develop your pipeline on your IDE, then you run it in Jenkins, it fails. You do a replay, you change something, you do a replay, then you get the modification, you copy back in your IDE, you commit again, you push in Jenkins. It's a bit exhausting. Yeah. And sometimes you have such an error, like you have an error in script 17, line 14. Okay, I don't know what script 17 is. So it can be a bit difficult to debug or to develop. And yes, something is not working well.
Yeah. So yeah, we recognized that these scripts were getting complex and complex. And when we touched the things, we could make some regressions also. So we could trigger the load test after the deploy to production into the production environment. That never happened, but we we were afraid of that. So we need to test and track the changes that we are applying to pipeline jobs, to pipeline scripts. That's why we created that framework, Jenkins Pipeline Unit. So until now, So until now, yeah, we already have continuous delivery pipelines described by code. Every pipeline is versioned in our code base. But now we have Jenkins Pipeline Unit, which unit tests everything that we want, and we can know what will be executed. And it is open source. Yeah. Go check it out, make a star.
Feel free.
Yeah.
Let's go time to demo.
Yeah. Let's see how it works. So I have my IntelliJ here. Everybody sees it. Yeah, it should be fine. So as an example, I have a really small project. So this is my project. It's written in Gradle. It will compile GUI. And to enable our pipeline unit testing, we import the jar artifact, which is available in the Maven Central as test compile. And in that same project, we have a Jenkins file, which describes 2 stages, really simple. And let's go ahead and write a test file for that. Let's see, test Jenkins file. I'll create my class. So the framework already gives you a simple test that you can extend, which will set up the test itself. Base, pipeline test, I will extend that. Maybe I forgot to tell, we will use JUnit, but you can't use any other framework like TestNG and Spark. Yeah, people use Spark also in GUI. So we need to first set up the base pipeline test, and then we can go ahead and create a test method. I'll call it should execute Jenkins file correctly. Okay, and again, that by a base pipeline test, it lets you run scripts. So I will just name it Jenkins file. And with that, the framework will take your pipeline script, parse it, load into memory, and run it. And along the way, it will register all the method calls so that you can do that. So call stack is what we call for a stack trace. We register all the method calls so we can print all the call stacks. So let's see what it gives. Oh, well. It says, OK, no such property SCM. Let's go ahead and look. What was it? Oh, yeah, I have the thing, Jenkins file 3. Yeah. Oh, of course, we have the multi-branch pipeline, and Jenkins injects SCM property for those. Yep. So where's my test? Yeah, here. I can go ahead and mock this property with the framework. So I will set a variable in the binding, which is the basic context object that is passed to scripts in GUI. So with that, we'll re-execute. Notice that I'm only on the IDE. So it gives you that, which is all the steps that will be called into Jenkins. Like it will enter a stage, a checkout, it will make an shell script, re-enter a different stage, and SH and JUnit. OK, that's good, but we never written assert. Usually when you test stuff, you assert stuff, you know? Yep. So yeah, we didn't want to assert all the different stages that we were doing, so we have written a simple regression test. For that, we will transform this base pipeline test to base regression test. And that base class that will let us do test non-regression. So let's re-execute this. And hopefully, again, I'm on the IDE. It says, OK, saving the stack into that file. Let's go ahead and check that file. I'll add that to this here. Yeah. So the same thing. OK. So I can go ahead and commit those, saying that non-regression test. OK. So in the same time, I have a Jenkins running a local. Yeah, here. Yeah. As I was saying, it was the integration job that was multi-branch, and I have a branch called Jenkins World. And let's re-execute it, but I don't want to use the blue ocean. Yeah, here, that's better. Yeah, I haven't pushed it because it's in the local. It will get the new changes. So with a bit luck, it should execute the test and confirm that what it's executing is the same thing. While it's executing, let's make some changes into our Jenkins file. Let's add a new stage. And what I want to do here is to write a manifest, which will contain the Git revision, the current Git revision. So I need a manifest file, a file name, manifest text, and I will execute a shell script again. No, maybe not the script like that. Git parse. That should return me the SHA-1, which I will return from the standard out, right? Script. Oh, yeah. Yeah, thank you. That's the advantage of being two. So then I'll write the file. A file is manifest file, and what was it? Text? Text, yeah. Text is
your
revision. Yeah. let's go ahead and archive that so that we have the Jenkins shows us in the job. So let's re-execute our test and see what it gives. Again, OK. Oh, it says I couldn't know what the write file method is, which apparently takes a map. So obviously, we don't declare every other step that is available in Jenkins, and with the, lots of plugins, it will be impossible. So rather than that, we let you mock the steps that are available in Jenkins. So we let you mock any other step saying that I will register a method to this helper object that is the core of the framework. The name of the step is write file. It takes a map, and that is basically a closure which will be executed, and it can do whatever you want. Let's re-execute that. Oh, it will say the same thing for, of course, the archive. I'll register a method, archive, which will take a string, and I will do nothing. If we start it, we can also mock the shell script also. Yep, I have already prepared that. Oh no, not that. Mock web parse, yeah. I don't want to type that. So let's see what it gives. OK. So that updated the call stack with the new stage. It validated all the steps, because we already registered in the test. And with the mocking with closures, we also get the SHA-1 that we mocked. So let's take a look at our Jenkins. Build success. Great. So for the new changes, I want to show you by only committing the two files, so that the Jenkins file will stay the same. Let's say write manifest. Notice that all the coding and testing I was in the IDE. So let's re-execute our job. Again, I can do some other refactoring. While I'm at it, let's see, that rev parse head, it can be reused somewhere else. So I'll get a method with it, rev parse, yeah. And for it to be used somewhere else, I want to create a file containing only that. Let's say utils.jenkins. That is in source main Jenkins. OK. So let's jump into that. I'll copy this method and into my utils.jenkins. Again, return this for that the method will be used. And go ahead and Jenkins file. Now I can do this. Declare the utils library. And after my checkout, I will load it. Utils load src main Jenkins and utils.jenkins. Yeah. And now I can call it by saying utils.reparse.
So how is it going in Jenkins, actually?
Yeah, we can take a look at that.
Oh, yeah.
OK. So it says there's something not well. I bet it's the test, right?
Yeah.
So it says that, yeah, you want to make this change, but when I parse the Jenkins file, my unit test says that that's not the call stack that I'm expecting. So with that change, I can go ahead and re-execute the test. Okay, so I just did the refactoring and it goes well. It's, let's say, updated the call stack file with the load, and yeah, it says there's a rev parse here, which is a method in the utils that is called, and at the end, it's the same exact write file. So I will commit all these, saying that rev parse method in utils. And if I re-execute the test, all should go well. So just now, we added a new stage in the Jenkins file. We tested it locally. We did some refactoring job, again testing locally. We created some mocks for the steps, for the variables that are injected by Jenkins, and also we see what are the exact steps that are executed with the parameters that are passed to the method calls. That seems nice. Okay. And I have the manifest file here, which contains that. Okay. So let's get back to our presentation.
So to set up a Jenkins pipeline unit configuration, you just have to add the dependency to Jenkins pipeline unit, extend the base class, and then you can mock variables or any method you want, any Jenkins step you want, even from plugin. So it's pretty easy. I give you, yeah. And the features are unit testing, debugging in ID, print the code stack to see what happens actually, and doing some non-regression tests.
Yeah, notice that we only mock the steps. The steps are not really executing on the machine. So how does it work? So first we transform the code. We of course load the code into the script engine of Groovy. We transform it with the same transformer that the Jenkins uses to apply the continuation passing style to that script, which lets Jenkins to stop and start jobs and save the state of the execution. So yeah, then we can inject some variables with using binding and run the script with Groovy script engine. And also we use the meta class of Groovy Magic to intercept the method calls and register them into the famous call stack. Then we can mock the steps and so on.
So you would say, but there is Jenkins rule as well. Jenkins rule is something you can use with JUnit. And it spawns a Jenkins instance so that you can test in a real Jenkins instance. But it's awesome, but it works pretty well with plugins. And it's mandatory for UI on the plugins test. But it's much, much slower. And every time you need to spawn this new Jenkins instance. And when you are just testing your 20-line pipeline, you don't want to spawn an instance. You want something quick.
But of course, it's more representative.
Yep.
So what we suggest you to use when, if you are developing a plugin, you should use the Jenkins rule, of course. I've heard in these sessions that there's a restartable Jenkins rule to see if the job or the plugin that you're writing handles the restart well. But if you are developing a continuous delivery pipeline for your organization, you can use Jenkins Pipeline Unit. If you are developing a global shared library that will be shared among other organizations, you can use Jenkins Pipeline Unit. And we only use the scripted pipeline pipelines, but it can be also used with declarative pipelines. It's just that usually when you are at the declarative pipelines, usually you do simple steps. if you use some scripting into declarative pipelines with some configuration, you can use the Jenkins Pipeline Unit.
So with Jenkins, with a pipeline tested, you can do rapid development on your environment. All the life cycle will be quick. You can test locally, you can change, refactor, do all the things you want. And then when you are confident with your code, with your pipeline code, you can push it to Jenkins and it will run, and hopefully perfectly. So thanks to that, it breaks the boundaries between dev and ops, because both of them can develop a pipeline and test it. So it's nice.
Yeah. So we sense that in our organization also at Left4A. 2/3 of the developers were developing pipelines. As again, we were just Java developers at Left4A, and we did lots of changes into our pipeline. Some of them we already talked of that, but like cache warm-up, we did with Jenkins pipelines. Lots of automated commits that we are doing. Yeah, automation of deployment scripts like lazy packaging. Yep. Yeah, the shared workspace, we already talked about it. The Dockerized database within the tests. And we get really nice Slack notifications. I guess everybody's happy with that. As long as, if you push a branch and it breaks some tests, you personally get a Slack notification saying that 5 tests are broken into that branch, etc., etc., and with a link to the pipeline, the Jenkins link to our Jenkins. So again, we open source it. We should start it again, and the community started using it. Yeah, Bill Dennis used Jenkins Pipeline Unit for testing 6,000 lines of code and 12,000 lines of Spark unit tests. And again, yeah, the Japanese comment is why Jenkins Pipeline Unit is not working with linting of default lint of Jenkins. So we should take into that. Yep, we should take a look.
So with Jenkins Pipeline Unit, you can do unit tests again, print your call stack to see what happens, do non-regression tests, debug in your IDE. What is not fully supported are declarative pipelines. We could do it better. Any help is welcome.
Yeah.
And some people want to use it with lint, so maybe we could work on it as well. And again,
yeah, it goes with it. Yeah.
Yeah.
So yeah, thanks for coming. And again, we have lots of open source projects at Left4A. Jenkins Pipeline Unit and Git Octopus are just 2 examples. And yeah, what other news? Maybe we will be passing the project to the Jenkins organization. We are talking for that.
Yeah.
Yeah. So that everybody can use, and there will be a tighter integration with Jenkins core. Again, the slides will be available at Left4A conference at GitHub. Any questions? Yeah. Oh yeah, the question is, are we writing the Jenkins files with TDD, test-driven development? Yes and no. Usually, we have a base pipeline script test that declares lots of different steps, right?
Actually, you can do partially TDD.
Yeah.
If you want to do some small method, you can test it. You can do some unit test first and do TDD. But as you can see, the non-regression test is not possible to write it by your own, so you cannot do TDD for that.
Yeah. But usually what we do is to declare the steps that we will use first, and then maybe we'll mark them, maybe not, and then write the pipeline script, and then start testing, and then doing configuration stuff, and then pushing to Jenkins. But we usually start writing the script into our IDE. Yeah. I can't hear it. That's what we did. That's what we did. Yeah. In here.
Actually, even here.
Right. Blue Ocean should give us a better.
Okay, here it's a bit cheaty because the build is doing nothing.
Yeah.
But in our real application, the build is really building the application, running all the tests of the application and the test of the pipelines. So everything is gathered, and if you don't pass it, then you won't be merged with other branches.
How do I see the tests in here? Yeah. Test Jenkins, but it just tests itself first while while executing the Jenkins file.
Other question here?
Wait, I will open it and we'll discuss. Yeah, in here. That's the old one. That's the new one. Oh, MariaDB. It's the logo of MariaDB. Yeah.
Yeah.
Oh, too bad. Which one? I must have made a typo, I guess. Let's see. Lefure conferences. Shouldn't be it. Let's see.
What?
There it goes.
Yeah.
We didn't upload the slides yet. Yeah, but we'll do just after that.
Can you hear?
You are too far away. There are examples in the project itself. So the project itself has lots of different pipeline scripts and the tests that are done into those scripts. So we test the project itself like that also. What we didn't yet do, what I should have done long early, to create another project with lots of examples and so on. So, but it should be done maybe next month.
A question?
So yeah, we are in a bit early. Yeah.
Yeah.
Great.
Then
thanks for coming.
thank you, everyone. I hope you appreciate it.